Hey guys, this is William. And this time I'm gonna be helping like doing the stats stuff. This is gonna be exam number 3, and I'm gonna start off with number 1. Alright, so according to the U.S. Census, there's a distribution in 2008 for like the old people, and it describes about the ages and stuff. So what they give us is a random sample of 626 and a lot of percentages and a lot of observes. So what we want to do is we want to list down the uh, the observed of the 626 seniors. So the first one is 300. The second one was 232. These are just groups of ages 92 and 2. This is what you're going to put in the calculator. So this is going to be expected. Now this one's going to be expected, and list 2 is going to be observed. The list 1 is going to be observed, and the list 2 is going to be expected because we observed in the sample, but what we expected is the percentages, which is 0.58 times 626, which equals you could just keep on doing that 0.322 times 626. We want to keep on doing this all the way down with all the different percentages because we want to get the expected value. And if you plug this in with a goodness fit test, we should get like a really small p-value. It's going to be like a p-value of 1.102 times 10 to the negative 8, and we could see that D is the right answer because there is evidence of a significant difference in distributions at the 0.001 level. That means there's a huge difference even at the smallest level, even at the smallest p level. Alright, number two is a high school administrator wishes to compare state assessments results male and female students. Which graphical display wouldn't it let you recommend him? Like, if you want to compare students, back to back, I'm gonna just go through the list, but B and E are pretty much the same thing because stem plots, histograms are just the same thing turned over, and so you could cross out B and E. Compare dot plots. I don't think dot plots would really help because you just have graph lots of dots, and they're just like really random, and pretend you had what you want, and huge dots everywhere. Alright, it just doesn't really help. And the scatter plot, that's the same thing, almost the same thing as the dot plot. So I would just pick box plots just to compare their medians and their spreads. So that might be like that between the male and the females, and another state might have been like this. So this is like probably the most effective way of comparing. So it's going to be D. Next. So, in a small town of 500, the last census reported the average. So, whenever we see average, we just want to go straight to t-test average, because whenever you see average, t-tests are always meant to be for averages. And you have a small town of 500, which n equals 500. Just always list the givens out. And the average income is 34K. But before the next census in towns wants to determine whether it's average, CILT test has significantly increased. What I would do is I would just check the conditions and start crossing things out, because right here it asks whether one would have affected the other, which is also a test for independence, and any if oh yeah the end the what you call it, oh my god, I'm brain dead. It has to be lower than 10% of the total population that we're having right now, which is at the end. So it's going to be less than, it has to be less than 50 for it to be independent. Independent. And we could cross out A through C. And also, we could also cross out E, because yes, it does have the t-test, just that the degrees of freedom are way off. Degrees of freedom is not 499. There are not that many families for that random sample, so it would be n minus 1, correct? But in this case, it would be 30 minus 1, because the 30 families are below the 10%. It was a little confusing for me, but yeah, I'm so tired. So two random variables x and y are independent. Yay. X has an expected value of 2.5 here. X, y. So x has an expected value of 2.5. X has a value of 2.5 and a standard deviation of 0.3, and y has an expected value of equals 4.7 and standard deviation of 0.4. Which of the following is true? Oh, yeah. So, what we can do, usually you always want to check the standard deviations, because the testers, always want to trick you to add and subtract standard deviations wrong. So what you want to do is add. They would usually expect you to add standard deviations directly, which would make a mistake of 0.7, and you would either get answers B or C. However, to add standard deviations, you must add the variances, which is standard deviation squared. So this is going to be x, standard deviation x, standard deviation y, x squared plus standard deviation y squared, all under the square root, which is equal to 0.3 squared plus 0.4 squared, all square rooted. I'll scroll down a little, which equals 0.5. And that's your standard deviation. That's the only standard deviation there. Circle E and you're done. Alright, I want to just pause. I'm getting a little tired. Alright, I hope that helped. I mean, through 1 through 4. I mean, it's helping me. Just like reverberating. Reiterating this verbatimly. Anyways, yeah, I'll just keep on